All right, so for all of you on school visit at Thomas or out recruiting for us, I know what you were doing. You really just wanted to skip my class. So my feelings are hurt, but it's okay. We're all disappointed in you.
Hey, you're back.
Not you, Ethan. We're disappointed in the people who aren't here.
We're disappointed in you.
We know that they're intentionally skipping my class just to get out of math too. All right, but for real, we are going to talk about this quiz. So in questions 1 and 2, it asks you to find the equation for the axis of symmetry, and then find your vertex. So how is it that we found our equation for the axis of symmetry for any quadratic? Now, give me a second while I go holler at people.
Yes. It's recording.
Ladies and gentlemen, can you please do what you're supposed to do so I can continue teaching? Thanks. I would hope that your peers would help you correct your behavior, but it seems as if you don't have very many people deciding to lead right now. Same goes over here, and you're reading, so it's even easier. You do what you're supposed to do so I can do what I need to do. Because imaginary numbers are very difficult to understand. Which I'm hoping we get to that video, and then I can just repeat it tomorrow if we need to. But so, I posted on our Schoology, by the way, I posted an entire playlist of videos about imaginary numbers put up by Welch Labs. They're really, really good. They're better than anything that I could ever make. So check them out if you're trying to get a better understanding of complex numbers. It's on our updates page on Schoology.
Is it the grape juice company? Welch's?
No, that's Welch's. Thank you for always trying to make it something funny.
Sorry.
So, how we find our axis of symmetry here, and this sucks because it won't let me write on PDFs. We always actually just want to do what? Caleb?
Well, you asked how, and I think I did it a different way than you wanted me to.
Okay.
Let's figure out the answer right. So, isn't there an equation? I'm pretty sure it's negative b over 2a, right?
Yeah.
Axis of symmetry?
Yeah, we kind of slowly piece together our quadratic formula, but the piece of it that is negative b over 2a, that gives us our axis of symmetry. So, in 1 and 2, we just take their b values, where in 1, what's the b value of 1?
0.
Of number 1. 0. So we're gonna get 0. Our axis of symmetry is at 0. And then when we plug that in to find the y value, it'll give us the vertex point. Which that is 0, 1.
Kind of odd.
And then in 2, if you had any issues, that was actually 2, 0. Does anyone want to see anything more on number 2? With graphing each function, some of us had issues with that as well. If you're going to graph it, like manually, the first thing you'd be good to find, like if you want to start your graph somewhere purposeful, would be what?
0.
Well, we could find a 0, or what we just did in 1 and 2. We could find the axis of symmetry, which in turn really finds our vertex. Once we know the vertex, work left or right out from each of those points. So, in 3 and 4, are you looking for 12-8, the complex numbers one? Yeah, and then these notes. Oh, you have the notes, alright. So, again, in number 3, not again. Our b there, we don't have a c, we do have a b. So we have negative b, so negative 8 over 2a. So it'd be negative 8 over 4, which gives me negative 2. My vertex starts at negative 2. I find out that my vertex point is actually negative 2, negative 8. And from there, I can work to negative 1, negative 3, 0, negative 4. And I have found 5 points to make my parabola. Same thing in number 4, negative b over 2a. Except here, that gets funky, because that turns into negative 1/6.
I was negative 1/6.
Positive 1/6, because negative b, yeah, good catch. So it's positive 1/6, and then you plug that value in and get your output, which is messy decimal.
Question: you said no graph, but I drew a graph.
I wrote that first, and well,
mind you, it's not a very good graph.
Yeah, well, that might have been where I was going for.
It's like this.
Oh, I didn't write no graph. I put graph question mark. But oh, look at this.
Well, I mean, okay, I drew it before and then did the values, so I just added them. I just drew the negatives on
His
this.
negative axis is going right.
Okay.
That's why I didn't put graph question mark like where is the graph. I put like look at the graph,
Okay.
and that's why I put that.
Hey,
You're-
if it
so,
works, it works.
You essentially took your Cartesian plane and did this.
Yeah, but is that a bad thing?
I mean, it's not a good thing. Don't
It's
do
not a
that.
bad thing.
Yeah, it's a bad thing. So
Why?
don't do that.
Yeah.
I'll let it slide for this time, but don't do that. Hey, don't call me.
Yeah, David.
Just a prank, bro.
Alright, now, this, 5 and 6 are really what I wanted to talk about because a lot of us just kind of locked up and forgot what we were doing. In 5 and 6, when it asked us to find the equation in standard form, we could do all that nonsense of setting up a system of equations using A, B, and C and solving for the 3 variables. Plugging in each x and y pair that we have. Gentlemen, did you get 5 and 6 right?
I got a check.
He
He didn't even write an answer and he got
Oh
a
no, then
check.
I left it blank because you have it not finished.
Oh, okay, sweet.
Because I was debating whether I was going to have you guys finish or whether we were going to go over this together or what. We might do the G form of this like together at some point just to make sure we're good. So, again, as a reminder for that process, what do we do? And we don't have graphing calculators for everybody today because the other math class is using them. And we could go get them if we really wanted, but we don't need them. Let me get this loaded up real quick. What do we do with these 3 points to get our calculator to spit out my equation for me? Yeah?
Can't you just plug him into the list?
So, how so?
I don't know.
I agree with you. We plug them into the list, but how do we do that?
What do you mean? How do you do it?
What goes where?
Oh, wait. I don't understand.
So, I have these 3 points,
Okay.
right? And you told me to plug them into the list. So, alright, I go to my list, edit. We actually screwed this up the other day. This sits right by my chalkboard. It gets kind of chalky sometimes. So once I go to my list and I edit. Sorry, this needs to focus.
So when you tell like what numbers to put where?
Yeah.
Okay, well there you put like -4.
So, and this, for some reason my L1 has disappeared. So I actually need to retitle that list as L1. So now if I want to clear that list, I just hit clear and then hit enter. Same with L2. If I start bumping over. This is being really weird. I don't know necessarily. So I can use any of these lists though. So for some reason there's some issue going on with my L1, but I can use L2, L3. Then when I plug them in, I just got to use L2, L3. So you said -4. What's the next thing I plug in?
-1.
-1.
3.
So all my X values. What are you looking for, Gunnar?
Oh, just like that's just like 83.
The graphing ones. Here's my fancy schmancy one.
See, there you go.
Make sure I get it back though.
He didn't want to interrupt you.
/Phoenix/ my baby. Well, that's a really fancy calculator. All right, so my X's are one list, my Y's are my other list.
I didn't understand the question, but I figured it out.
So then, and this is really the how part of it, then how do I get it to do the work? So plugging them in is the very easy part of this. What do I do then? Because it's the operation, that's where it all comes down to. What's the function that will generate my quadratic, my quadratic equation? Megan? So what's that abbreviation for?
Quadratic.
Regression. So we want to look for our quadratic regression. So if I go over to calc, Sorry, this calculator's got like kind of a busted screen. But the fifth is quadratic regression. Now I need to use whatever lists I used to plug those in. So I input list 2, since I used list 2, list 3, and list 3, and it spits out my A, B, and C values. Hall has the other ones because they're using them in that class today, so we're just going over this together. And I told the other guys, we're probably going to do another version of this quiz. I'm not going to put these in Schoology, actually, just because I'd rather use this kind of as a formative type thing. So if I do that again, and I edit my lists for 6, I just plug in my x values, -1, 0, and +2. My y values of 9, 4, and 6. I then could actually go back out to my menu. Oh, crap. So make sure that you exit before you start playing with things, because that was about to totally screw up my list. So quit out. Now if I quit this, well, it already ran the quadratic regression, but if I just hit enter again, it'll run it again with my new values. So note, I did not retype anything. All I did was hit enter once I got back to my main screen. But if I cleared this and it was gone, then I can go back, stat, calc, quadratic regression, grab whatever lists I used, and it would run it again for me. So that's for 6. So that would mean 2x squared minus 3x plus 4 would be your equation. Any questions on 5, 6? So we plug the lists in, and we go from there. Yeah. 3.
What was it for number 5?
So actually I'm just going to show again how we did this, might as well, since I don't remember. -4, -1, and +3 for my x's. My y's are 3, -6, and 10. And then, so check this out. This is where my calculator is really cool. If I second quit out of this, it's still showing me the results from running the regression, but since I use the same lists, if I just hit enter again, it reruns it with my new lists. So then I get 1x squared plus 2x minus 5.
That's pretty rad.
Radical.
Rad.
Oh god.
Rad.
So do you want us
As
to
in
revise this
the
test or what?
calculator.
Yeah, just so you have it as a reference.
Okay.
Should we turn it back in? Like, I got it.
No, I'm not going to put this in map. We're just going to use it to check our skills. So finding square roots, this was all just straight algebraic skills. And I'm actually going to switch screens so that I can write on my smartboard. So when we look at solving by square roots, we're really just manipulating to get the variable by itself. It's these really math 7 skills. So if we have x squared minus 18 equals 0, that really, 81. That's really saying that x squared equals 81. We square root both sides. We would get that x is equal to...
9.
9.
No.
What?
Wait, x is equal to 81.
9 is negative 9.
9 is
Positive or negative 9. You have to have both options. If you only have one of the solutions, you're only halfway right, which means you're all the way wrong. Same thing with 8, except it's a bit more complicated. When we have a coefficient in front of the x, especially when we have it in front of the x squared, ask yourself, can I factor out anything common from the whole expression before I start? 192 does have a common factor of 3, so if I factor out the 3, this becomes x squared minus
64.
64. I can essentially ignore the 3 now. And x squared minus 64, that all equal to 0. So this, in the parentheses, has to equal 0. I can physically ignore the 3 because nothing that I do with x will make this 0. It's just I need this to become 0. So then what we see is x squared equals 64, and x will be positive or negative 8.
Oh, I guess I did something on the calculator because for some reason I remember this question giving like a really funky value.
Did you try to put it in the graph, or did you try to like do
No,
that?
just like literally Just
When you square root in your calculator, it only spits out the positive.
No, not square root. As in, I literally just did 192.
No, when you do the second thing, it could mess up and do the whole.
No, I mean literally 192 divided by 3 did not give me a number that could be squared. I think I just did something weird.
It doesn't have to be squared.
No, sorry. Something I gotta take the square root of. I don't think I got 64.
I see. Did you write anything down that we can figure
No,
out?
so I just got confused because I put no solution. So
You didn't have anything written down. We can't really figure out what you had done.
Caleb,
Let's keep moving.
Yeah, I know.
you did it.
I didn't do it wrong.
You did it wrong.
When we solve by factoring, guys, again, we're trying to factor out a common factor, but here's the mistake that I saw people making. For number 9, we start with x squared equals negative 6x, and we can make this quadratic or equal to 0 by making this plus 6x, x equals 0. What common can factor out of both of those?
6 and 1. 6.
X can factor out of both of them.
You tried, Brian.
So when it's x times x plus 6, what's one thing that could immediately make that expression on the left equal to 0?
Negative 6.
Negative 6.
Easier than that even, and this is, I think, why people are forgetting.
0.
When you have an x out front, immediately that tells you that one of your solutions is 0. Then we can look in here and see our other solution is negative 6. The issues that I was seeing was people were forgetting their 0 because they were only looking at this binomial. Well, we've also got the monomial out front. That could also make this expression equal to 0. In 10, slightly a bit more difficult. It was x squared minus 7x minus 8. So there's nothing common that can factor out of the whole thing. So instead we look at factoring it out into 2 binomials. We're looking for 2 values that would have a sum of negative 7 and a product of negative 8. Yeah?
Negative 1 and negative 8.
Ooh. Careful.
Oh,
If they
right.
have to produce a negative number, one's got to be positive. So I can use negative 8 and positive 1 because this value has to be negative. I know the bigger number has to be negative, which makes my solutions here 8 and negative 1. A couple people had those switched around, their signs switched. Any other questions on 9 or 10? In 11-12, we were completing the square. So again, this is probably the hardest part from the beginning of this chapter. So we had r squared plus 6r equals 16, and this is 11. And there's a few different methods for completing the square. I forgot to mention this when we taught this, but if you Google this and if you go start watching videos, everybody kind of does it differently. So what we did in class was we brought everything over to one side. So we said r squared plus 6r minus 16 equals 0. And then we essentially said, well, if this was a perfect square, this value would be something different. But what would we want to get that value? Well, what number, when doubled, would get our 6r? All 3. Sorry, this is not r squared. This is just r in here. So this is a big hypothesis right now. If this was perfect square, that's what would happen. But then this value would actually have been, well, if it's r plus 3 times r plus 3, 3 times 3 would give us
9.
9. So since that needs to be 9, and this is where we get screwed up, what do I need to change, which really I'll have to do it on both sides, to make negative 16 turn into 9? Well, I got to raise it by 25. So this really becomes r squared plus 6r minus 16 plus 25 equals, and well, I did that on both sides, so I get equals 25. But what that breaks down to, sorry, someone's on the roof doing work, and every time they walk across my classroom, it is as if the smartboard is alive.
Earthquake.
and this becomes r plus 3 squared. But we still need to make it quadratic. So we again move my 25 over, and now we can see horizontal shift, vertical shift.
You have to do it that way.
That's the completing the square method. I mean, there are a couple other manipulations of the completing the square method, but yes, you need to understand how to complete the square, because not only for you need to understand it because that's a part of our mathematical understanding as we work towards the future, but the test very well could say, in this solution box, show the process for finding the zeros with completing the square. Or finding the vertex, at least.
I just got in parentheses r plus 8 and then the parentheses r minus 2. That makes the exact same answer, just a lot less complicated.
But it's not a completing the square process. You factored and found the zeros. Completing the square finds my vertex. Because now I know this is actually a shift to the left 3 and down 25. So my vertex is now counterintuitive of what's happening in the parentheses, exactly what's happening outside.
Okay.
So negative 3, because that was positive 3, negative 25. So that's our vertex there. Yeah.
The question asks for the zero.
Yeah, I know. So then, if we're trying to find this, like, that, I'm just justifying why we do the completing the square method. Other questions on how we do completing the square? We're just looking for what constant value could make it perfect square. The roots of the equation are just the solutions. So you could have written any of the quadratic equations that we worked with or made one up and shown how you find the roots. And most of us on 14 were pretty good at identifying it's just the slope or the intensity or whatever else we want to say about that. That makes the difference between 5x squared and a fifth x squared. So yesterday we talked about imaginary numbers and had some decent struggles because it's a very complicated idea. Thanks to Welch Labs, I think, yeah.
Sorry, could you do number 4 really quick?
Well, we had done it, or we talked about it, but let me. So we would first there in number 4 want to find the axis of symmetry to find the vertex, and then find points working out from there. So number 4 says graph it. So to graph it, we need to know what points I'm gonna graph. 3x squared minus x minus 10 is equal to y. So to find our axis of symmetry, as you did in number 1 and 2, we use the equation negative 2a, or sorry, upside down. Negative b over 2a. That will find the center of your parabola. So that becomes 1 over 2 times 3, which is 1/6. We then can plug that value in to find the y value there. So we say y will equal 3 times a 6th squared, which is going to be 1/36, minus a 6th, minus 10. And actually, FYI, just in case you guys were frustrated by this, this was actually a typo. The test key, at least, had one that had no minus x, so it was way easier. But I leave it like this because it's a little tricky, but it's not terrible. This becomes 3/36, which will reduce, but this is 1/36 times 3, minus 1/6, which, since I'm actually going to end up working in 12ths, I'm going to go ahead and put this in 12ths, minus 2/12ths, and then minus 10. So this is 1/12 minus 2/12ths. So we really, with these guys, get a negative 12th. Then minus 10. So my y is negative 10 and a 12th. And 1/12 is like 0.08 something. I memorize a lot of things, but not that.
0.08333333.
Yeah, because it has to do with threes. It's like thirds. other questions from any of the rest of the tests, and we'll take a couple more when the rest of the class is back tomorrow. But you guys are gonna get an advantage because we may end up rewatching these videos as a class. But if we do that, then you'll have time to work on homework or whatever else. But so this playlist, I'm gonna show you guys that it's posted on our Schoology. That's email. Can't show you guys email. So I'm gonna pause the video really quick. So if you're watching the class videos, because I'm not actually, can I turn this on? I cannot turn this on. I do not have the computer audio on, and it wouldn't be very good. And I'm pretty sure I would infringe on some copyright if I'm putting somebody else's YouTube video in my YouTube video. So if you look up Welch Labs or Imaginary Numbers Are Real, this is an amazing playlist. But I'm going to end our class recording so that we can play this video. So if you're one of the people at school visits or whatever and you're watching this, I would go look this up and watch the video on your own.
Wait, Mr. Hudson.